So continuing the discussion on proportions versus means, if we have a two-sample test of proportions, that means we are looking at two different samples, and are they significantly different from each other? But just like our independent samples t-tests, it's two different groups, but we have proportions instead of averages. The assumptions are the same. The equation looks a bit different, and don't panic, it's not as bad as it looks. So we still have one group minus the other. We still have this p minus 1 minus p divided by n. So we've seen this before, and then we're adding both groups together. So it's really similar to a pooled t-test. If we have an Acme drug company that develops a new drug, and it's to prevent colds, and the company is saying that the drug is equally effective for men and women. So there's no difference between the groups. To test this claim, they chose a random sample of 100 women and 200 men from a population, which we don't need, but we have population information. And at the end of the study, 38% of women caught a cold, 51% of men caught a cold. So there is a difference between these two numbers. But is it significantly different? So is it equally effective for men and women? And we, of course, are going to use a 99% confidence level because this is medical. So going back up here, our research question is men and women, are the groups different? So our null is that men is the same as women. And our alternative is that they are not equal. We are not curious if women are higher or men are higher. We just want to say, is it equally effective or is it not equally effective? It's medical, so we are a little bit more high stakes. We want to use a higher confidence level and allow for less error, only 1%. The test we need, we have proportions. We don't have means, and we have two samples, so it's a two-sample test of proportion. So calculate the test. Doesn't matter which one you put where, but I'm just going to put women and men. So this is going to be P1, this is going to be P2. My proportion, 38% of women got a cold out of 100 women, and out of 200 guys, 51% got a cold while using this. So we're just going to plug these two numbers, so watch what P1 is and P2 is. This is N1 and N2. And we're just going to plug in all of the numbers into our equation. Solve for Z. So press pause, get out a piece of paper, and solve. Press pause. When we do that, we get a calculated value of Z equals 2.165. Or close to it, depending on how you rounded throughout that process. Proportions, you get such small numbers, you have to watch that. So we need to know, is this significant? So we are, again, going to Google Z2P calculator. We're going to use the social sciences one. It's a good one. 2.165. Our significance level is 0.01. It is also two-tailed. We're going to say calculate, and our p-value is 0.03, which is not significant at 0.01. So going back here, our p-value is 0.03. So if we wanted to be 95% confident, we would have found a significant difference. But because we are allowing for less error at 99%, comparing up to our alpha, this one is greater than it. So it is not significant. We failed to reject the null, meaning there is no difference, aka the drug is equally effective for men and women. Since we failed to reject the null, we might have made a type 2 error, but hopefully not.